Good morning, students. So, welcome back for our today's session, that is deflection of beams. Okay, so today we'll solve one more problem for the calculation of deflections of prestressed concrete beam with there is a small different arrangement in the beam. So before starting, I'll read out the statement of the problem given. Okay, so the problem is like a prestressed concrete beam of rectangular section 150 mm wide and 400 mm deep is stressed by 4 cables, each carrying an effective force of 250 kilonewton. Span of beam is 12 meter. The first cable is parabolic with an eccentricity of 50 mm below the centroidal axis at midspan and 50 mm above the centroidal axis at supports. The second cable is also parabolic with zero eccentricity at supports and eccentricity of 50 mm at midspan. The third and fourth cable is straight with a constant eccentricity of 50 mm below the centroidal axis. If the beam supports a UDL of 10 kN per meter and modulus of elasticity of concrete, that is EC, is equal to 400 kN per mm square, estimate the deflection at the following stages. So first case they are given prestress plus sulfate. Second case prestress plus sulfate plus lye load. Third case, if the loss ratio is 0.8 and creep coefficient phi is equal to 1.6, estimate long-term deflection. Okay. So according to the statement, we have the given data. Okay, just look out for the given data. Okay, so my dear students, look at here. So there are total 4 cables here. There are total 4 cables with different eccentricity. Okay, so what they are given? Cable 1 is parabolic and it is having the eccentricity at midspan 50 mm below the centroidal axis and at support 50 mm above the centroidal axis. Okay, again cable number 2 is parabolic, so with eccentricity at midspan is 50 mm below the centroidal axis and zero eccentricity at support. Okay, and cable number 3 and 4 is straight because they are given with a constant eccentricity, means the cable is straight, that is again 50 mm down from the centroidal axis. So understood, there are 4 cables. First cable and second cable parabolic, third and fourth are straight cable. Okay, so according to given data, okay, you have to understand and you try to draw the rough sketch of the profile according to the given eccentricities. Okay, so other properties are they are given the beam size as 150 by 400. Understood? Okay, then therefore area you will get, you can easily calculate area. Then they are given the prestressing force, then I, so I is dq by 12. Okay, then the span of the beam is 12 meter. Okay, the next is you have to find out the deflection due to prestress plus sulfate. Okay, so we'll calculate the dead load. So according to given, so we got the dead load as 1.44 kilonewton per meter, that is 0.15 by 0.4 into 24. Okay, then because of that we have got the deflection, that is 5 WL to 4 upon 384 EI. So you can easily calculate that again. So we got the deflection due to dead load is 12.15 mm. Okay, then also deflection due to lye load. So the live load is given 10 kilonewton per meter. So again delta LL is again 5 WL is to 4 upon 384 EI. Okay. E is also given. EC of the concrete is 40 kilonewton per mm square. So therefore we got the deflection due to live load also 84.37 mm. Okay. Now we'll next move to the next part. Okay. Now we have to find out deflection due to prestress. After the calculation of deflection due to dead load and live load, the next part is deflection due to prestress. So here they have given 4 cables. So you have to calculate the deflection due to prestress for each and every cable. Then you have to add for the all 4 cables. Okay. So we will take up one by one. So we will take up for cable number 1. Okay. So cable number 1, what they were given? The cable number 1 is parabolic with eccentricities. So what is the eccentricity? At midspan we have the eccentricity is 50 mm below the centroidal axis and support again 50 mm above the centroidal axis. So in this case it is shown. Okay. So according to that we have got the bending diagram. So that is 1 is plus, that is P into E1, again minus P into E1 plus E2. Okay. So P into E1, then again P into E1 into E2. So we can calculate the magnitude of that. Okay. By using that magnitude, again by using the Mohr's moment theorem, we can calculate delta PS AX bar upon EI. Okay. So that is 12.5 is P into E we have got. So that is again we can calculate AX bar upon EI. So we got the prestress, deflection due to prestress, that is because of cable number 1 we got minus 4.68 mm. So minus means upward. Okay. Next for cable number 2. So again the cable number 2 is parabolic. Understood? But they are given the eccentricity at only midspan. There is no eccentricity at support. Okay. So because of that we got the bending moment is only parabolic, P into E negative. Okay. So again, so it is delta PS. Okay. AX bar upon EI. So we have to find out area, that is half of the bending moment diagram, half of the parabola, into AX bar, that is X bar, that is the centroidal distance of parabola, half of the parabola. Okay, that is 5/8 of 6000 because total span of the beam is 12,000 mm. So that's why half of the is 5/8 of 6000. So we got the deflection due to prestress because of cable number 2 is again minus 5.86 mm, which is again upward because it is negative. Okay. Now we'll move ahead. Okay. Now because of cable number 3 and 4. Okay. So cable number 3 and 4 is straight because they are given, it is with constant eccentricity of 50 mm. Okay, means constant eccentricity means the cable is straight. Okay. So because of that again we'll get negative bending moment. Okay. So because of that, so we can calculate by using area method, that is moment area method, Mohr's moment area theorem, or you can use direct equation, that is PEL square upon 8EI. You have to multiply into 2. The question is why? Because there are 2 cables. Deflection due to 2 cables. So PEL square upon 8EI into 2 number of cables. So because of that we got the deflection due to prestress, that is because of cable number 3 and 4 is minus 14.06 mm. Total it is upward only. So what you can observe, from in cable number 1 the deflection was upward, cable number 2 deflection was upward, cable number 3 and 4 deflection is upward. So we can see the deflection due to prestress is always upward. The deflection due to prestress is always upward because the upward deflections will be balanced by the dead load and live load, because the dead load and live load the deflection will be always downward. So to balance that we are giving opposite force by prestress. So when the deflection is upward, that will be balanced by dead load and live load, then we will get ultimately the compatibility, means upward is equal to downward. Okay. So next what they asked, first you have to calculate the short term deflection due to prestress and dead load. So prestress you have to add for all the cables. Okay. that is minus 4.68, minus 5.86 and minus 14.06. Cable number 1, cable number 2 and cable number 3 and 4. And 12.15 is because of dead load. So ultimately we got the deflection due to pre-stress plus dead load is minus 12.45. Okay, it is again upward. Okay, so next we got the permissible deflection as per code for pre-stress and dead load only. So they are given as one, that is span by 300, 12,000 divided by 300, that is 40 mm. So it is in permissible limit. Okay, so next move on to the deflection due to pre-stress plus dead load plus live load. Okay, so again we have the, because of cable number 1 minus 4.68, because of cable number 2 minus 5.86, and because of cable number 3 and 4 we have minus 14.06, and plus dead load is 12.15 plus live load is 84.37. Okay, so ultimately we got the deflection is 71.92 mm. Okay, which is downward. So when the beam is subjected to live load, the deflection turns to be downward. When there was no live load, the deflection was upward. Okay, and to balance that, when you apply live load, the deflection will be automatically downward. Then we have to check the permissible limit now. What is the permissible limit? So it is L by 250. Please look at here. So in the previous case, the deflection due to the pre-stress plus dead load. Okay, and the permissible limit for that, it is L by 300. Okay, but here when you consider live load, so the deflection, the allowable deflection, the permissible deflection will be L by 250. Okay, you don't have to take 300 because we are considering live load also. So it will be L by 250. So it is 48 mm, which is not okay, because the permissible deflection as per the rule is 48 mm, but our deflection is more than the permissible limit. So that's why it is not okay. So we have to check, only check whether it is within the limit or it is out of the limit. Okay, so here the deflection is more. Why? Because the span of the beam is more. It is 12,000 mm, 1.12 meter. Okay, so that's why the deflection is more. Okay, the next is we have to find out the long-term deflection also. Okay, now the long-term deflection is again the same equation, that is delta IL. Delta IL means because of load, delta IP means because of pre-stress, into loss ratio, that is final deflection divided by initial deflection, that is PF is not final deflection, PF is final pre-stress divided by initial pre-stress, into 1 plus phi, where phi is creep coefficient. Okay, so delta IL is because of load, so we have got 84.37 plus 12.15 because of live load and dead load, plus deflection due to pre-stress is, they are given, we have got minus 14.06, minus 4.68 and minus 5.86, into loss ratio, that is final pre-stress divided by initial pre-stress. So there is a loss, and the loss of the ratio is 0.8, and the creep coefficient is 1.6, so 1.6, so 1 plus 1.6. So ultimately we got the long-term deflection in the beam is 199.78. So we have achieved all the solutions. They are asked to calculate the deflection due to pre-stress plus self-weight. You have got that. Then again they are asked to calculate the deflection due to pre-stress plus self-weight plus live load. So we have calculated that. Then again they are asked to calculate the deflection, that is long-term deflection. So that also you have calculated. Now my request is, so you have to go through the video, and I am going to upload the PDF of this solution also. You go through, you solve. If you get any doubt, okay, you are free to ask the queries. we can discuss those queries. Okay, thank you.